Morning all. Hope you're having a good day. Here's a portable oscilloscope that my brother Jeff sent me, and we're going to take a look at it today. This is awesome. I've never had a portable oscilloscope before. I always had the suitcase size ones. They're hard to lug around, but this right here, this is fantastic. It's made by GWInstek, and it's part number GDS-122. We're going to hook it up, and we're going to look at the output of my invention right here. This outputs encoder and Hall effect in either differential or open collector. So we're going to look at the encoder output of this board right here on this portable oscilloscope. We'll put it through its paces right here. It's dual channel. This is channel A, and this is channel B right here. It also has some digital multimeter functions, but we're just going to use the oscilloscope side this time. All right, let's get close. Since we're looking at encoder output, we're going to look at the A and the B outputs with these two oscilloscopes right here, two oscilloscope probes. And we have the probes installed. Let's hook up our encoder and Hall effect simulator. Set that to about 10 volts DC. That's going to be the input to the 5-volt regulator of this board right here. Make a couple of probes right here. Okay. Okay, we got the encoder Hall effect simulator set up. Let's connect our probes to the simulator. This is ground. We'll hook that to channel A's ground. The grounds of channel A and channel B are tied together, so we only have to ground one probe. This is encoder A channel output. This is encoder B, A and B waveforms. Let's turn on our oscilloscope, see what we get. Enable the output. Let's bring the time back in. There we go. That's just too awesome. Okay. I'm going to move the camera in front of the screen, and you can see what output of the my encoder and Hall effect simulator is. There's the encoder A output, and there's the encoder B output. And you can see that they're 90 degrees out of phase. And the A, get close, try not to move this off the video screen, but you can see that channel A is leading channel B. And so we are rotating clockwise. And, I keep bumping this scope. There we go, sorry about that. So we're going to move in the opposite direction. Okay, now, channel B, this leading edge right here, is leading channel's A waveform. And so now we're moving counterclockwise. That's how, let's go back the other way. That's how a machine can determine direction. When channel A leads channel B, we're moving clockwise, and when channel B is leading channel A, we're moving counterclockwise. Counterclockwise, clockwise. Counterclockwise, clockwise. Now speed, I'm going to increase the speed of the output. Speed is determined by how fast we're moving in relation to time. We're slowing down, we're speeding up. It's the frequency. See how fast we're moving. Right there, according to the oscilloscope, we have 1.3 kilohertz. Let's see if I can slow down. Right there's 187 hertz, 160 hertz, there's 121 hertz, there's 74. That's amazing. I really like this oscilloscope. Now my big brother Jeff, he's the one that got me into electronics. When I was a little boy, he used to work around radios and whatnot. And one day, he threw an aerial over Mom's clothesline in the backyard from the second story of the house we had lived in up there in Connecticut. And he had it tied to a cat whisker radio. And we used to listen to the AM radio stations up there. And ever since then, I'd been really fascinated with electronics. But he's the one that got me into it. Got me interested in electronics. All right, all. I hope you enjoyed looking at this oscilloscope right here. It's a fascinating tool to have. Go out there and get you one of those and put that in your toolbox. All right. Now someday, this will be really complicated, but someday I'm going to put the schematics for my encoder and Hall effect simulator up on the internet, and I'll put the code up there too, so y'all can go out here and build one of these. But that right there, that'd be a hard thing to make a video of. It's very complicated. Easy to use, hard to build, and even harder to code. But let me turn this off right here. There we go. But I'll do that someday in the future. It'll take a while to make a video on that one. But this right here, they're still available. And so, y'all have a good day. Have you a good life. We'll see you in the next one. All right, girl. take you a nap.